Here we are at our 1.1 set of notes. We're looking at relations and functions. So a relation is a set of ordered pairs, and that relation can be in a lot of different forms. So a table, a graph, or mapping diagram. Very commonly, what you guys are going to see though are tables and graphs in high school. Okay, but there are mapping diagrams. They do exist. They typically pop up a little bit more though, like in your number theory classes. So if you're actually thinking about being a math person, but they do exist in math. You'll kind of see them here and there in high school, but the big ones that you encounter on a daily basis are tables and graphs. Okay, and when we're talking about relations, we're talking about a relationship between like an x value and a y value, and that's where things that we study like functions really kind of come in. To kind of help us with functions, we have what are known as the domain and the range. Now, the domain is the set of all the input values. So all of the input values. So in other words, everything that is going into a function, which is known as also the independent variable. Okay. For the range, that is the set of all of the output values. In other words, what you get as a result. And because of that, it depends on the independent variable. So that's why we call it the dependent variable. Okay. Now, often in times in math, when a teacher asks you, hey, give me the domain, they're referencing usually the x values, so your x's. And for the range, those would be your y values. And we'll talk a lot more about that in this unit when we dive more into our functions. Okay, so that's just kind of a quick rundown of some terminology of functions, domain, range. Now, here, as we look at example 1, we're trying to figure out what are the domain and the range. Well, the domain are all of our x's. And so that would include the 3, the 4, the 5, and the 6. Now we actually go ahead and write that as 3, 4, 5, and 6. Now, right now, what you've just said is, hey, these are my numbers, 3, 4, 5, and 6. However, to actually explicitly state that these numbers are in the domain, you actually need what's called a set notation. And all that you need to do is try your best with these little squiggles. Sometimes they're a little bit tricky for students, but just try your best on how to draw those. But that now becomes a set of those numbers within the domain. And yes, you do need those. Okay. For the range, super easy, super similar. It's just your y values. So we're looking at 1, 2, 2, and 3. So again, we have 1. Now 2 gets duplicated twice, right? So for our range, you really only need to say it one time to indicate, hey, it's part of that set. And then our 3. And again, just like the domain, you do need those squiggles to indicate that those numbers are part of that set. Okay. Now, again, that was a table. We're moving on to a mapping diagram, and it is very similar though. The first item, these are your input values, and these are your output values. The reason why we know that is because the inputs are impacting what our outputs come out to be, and that's where the arrow comes from. That's why our arrow is indicating that. Now, the input values, again, those are really just your x's. And the output values, those are your y's. And that really helps us then with the whole domain and range part. Now, for our domain, we do want to put our numbers in order. And so we can see that the top number is 7, and then it goes 5 and so on. But we do want to state them in order. And so we're going to open up our set. And it looks like the smallest number is 0. Then the next largest number is 2. And then we have 5 and then 7. And then we close that set with that item at the end. Now for the range, again, from smallest to biggest. So we're going to open it up, and then we have 3, 6, 7, and 10. And then we close the set. Okay. These, by the way, because it goes 0, 2, 5, 7 for the domain, and then those following numbers for the range, this is what we would call a discrete set. So it just goes 1 to the next, just integer numbers. So therefore it'd be discrete. But we'll dive a little bit more deeper on that later on. Now for this graph. Well, to kind of help us out, we're going to go ahead and state what are the first and end points. So this would be kind of like our start point, and this guy would be our end point. And the reason why we do that is because we always read graphs from left to right. So you're kind of reading your graph going that way from left to right, at least visually in your mind. That's how you're interpreting those. Now, what that first point is looks like it is at 1. We have that at 1, comma 4. And then we have to ask ourselves, well, where does this thing end? It ends at 5, comma, and then 3 for the y. So these are our 2 coordinates. And with always those coordinates, you have an x and a y point, and x, comma, y. Now that really helps us with our domains. That's why we actually jot down the points themselves first. And now let's go ahead and get into our domain. Now, for the moment, we're just going to go ahead and ask ourselves, where are we starting for the x value? Well, we're starting at 1 because we always read things from left to right for the domain. So we're starting with 1. That is the first x value that we actually have. Then we go all the way to 5 from that point that we just found. Now, there are a lot of different x values in between. So like, for example, there is a point at 3, comma, some y value. And we can find that if we really wanted to. But the main idea here is that there is an x value at 3 and some y value. Now, there is also one at 4. There's also one at 2. But believe it or not, there's also some even in between, like 3.5. Well, you could also even say 3.25. You could even say 3.10, 3.05, 3. I could say one that's 3.0000. We'll say 1, just to help illustrate. But the main idea that we're walking away with is that there are a lot of x values. In fact, there are so many that it wouldn't really make sense to write all of them out. In fact, believe it or not, it would be impossible to write all of them out because there's infinitely many of them. And so as a result, whenever it is connected like this, see how it's connected from one point, your start point, to the end point, you pretty much then just take the start one and the end one, and instead of commas and keep going, you would use a bracket. In this case, we'll do a bracket. And the reason why it's a bracket is because it includes those endpoints. Now, what this is saying is you're starting at 1 and going all the way to 5 for these x values. And it's everything else in between there, okay? We'll talk about what happens if you don't include the endpoints, but for right now, that's a pretty good summation of what we're talking about. All right. Now let's go ahead and clean this up so that we can talk about the range. Now the range is super similar. You are going to use your start and your endpoint to help you. But we always read the range from bottom to top. So for our range, we always read that from bottom to top. And again, that's because those are the Y values. And how we read our Y values are from bottom to top. So what is the smallest Y value, and then work your way up? Well, looking at our two coordinates, which one, again, these are the endpoints that we're looking at. Which one is the smallest Y value? Well, it's 3. 3 is smaller than 4. So then for our range, we're going to start with 3. And then we're going to go all the way up to 4. Now, because we do include these endpoints, like they are part of our graph, we again have that bracket going on. Now, because this is connected, you can see that it's connected there. It would include all those Y values in between 3 and 4. So it'd be like 3.5, 3.75, 3.8249. It would include all of those Y values in between them. And so instead of writing all those out, we just say, hey, this is where we're starting. This is my smallest Y value, 3. This is my largest Y value I have, 4. And it's all those numbers in between. Now for the graph one, because it was connected like that, we would call that a continuous. But we'll dive a little bit more into that in a moment. And then these guys where it kind of just goes one number after the others, we would call those discrete. So those are kind of like background terminologies that you'll see in future high school math classes. But discrete just means, hey, you go after one number, then the next number, then the next number, then the next number with those commas. Whereas continuous, no, there are a bunch of values in between, but we can't write them all out. We just have kind of like a start and end point. Okay. Go ahead and feel free to pause the video and ask any questions you might have. All right, now what I want you guys to do is pause the video and try out 1, 2, 3, and 4. What are the domain and range for each of those relations? All right, now that you've had the opportunity to try these out, let's see how we did. So for number 1, we have our domain being all of the X values. And we're seeing that it starts with -2. That is the smallest one. -1, 0, and 1. And then to make it a set, we need our squiggles. So there's our domain that we should have gotten for 1. The range. Again, we always want it from smallest to biggest. So we started off with, it looks like 0, 1, and then 4 repeats. So we only need to write it one time. And then obviously to make it a set, we have our squiggle. And that squiggle just takes practice. So if you're not perfect at it the first time, don't sweat it. For number 2, we have a bunch of different coordinates here. And so really that is an X comma Y, and X comma Y. We have X, Y. And again, the domain, let's change up colors. We'll go with blue. For our domain, we have all of the x's. So that would include the 4, the -2, the -5, but we need to order those from smallest to biggest. So we would start with -5, then -2, and then 4. So a lot of math teachers are pretty picky on the order. So if you need to pause the video and change those, I would advise you to get into that good habit. Simply because there are many math teachers who are pretty picky and will dock off if they're not in the right order. For our range, again, these are the y values. So it looks like we have 5, 6, and 12. So we end up, actually, those are in order already. So we have 5, 6, and 12. And we close it. We close our set with that squiggle. So that should be number 2. Next, moving on to number 3, we have our mapping diagram. Okay, and again, on the left side, this is like 99% of the time. The only time that they would, change it up is if they're trying to trick you. But really, all of our mapping diagrams, the left side are the x's, and the right side are the y's. Okay. But for our domain, which are the x's, we end up with 0, 1, 2, 3. Close the set. And for our y's, or the range, they're not in order this time, so we do have to kind of rewrite them in order. And it looks like if we did 5, 6, 7, 8, that would be the smallest to biggest. So 5, 6, 7, 8. Close it. All right. Now, again, that would be an example of a discrete, just because it goes from one number to the next, And now let's go ahead and see our last one, number 4. We do notice that we kind of have this line segment, and it is starting at -2, comma 1. That's where it starts, because we always read graphs from left to right. It's the first point that kind of occurs at. And then the end is over here. And that end point is 2, comma 4. Well, for our domain part, again, those are the x's. We're going to not open it with a squiggle because it is continuous. So we're going to open it up with a bracket because it includes those endpoints. And it starts with that first x value, -2. And then it includes all of these points in between until you finally get to this x value, regular 2. And because that is also part of it, we would close it with a bracket. For our range, which are the y's, we always read them from the top or the bottom to the top. So we're asking ourselves, based upon these coordinates, what are the smallest y value that I have? I see that my smallest y value is 1. So I'm going to start it at 1. And then I go to my largest y value, and I see that that's at 4. And because those endpoints are part of it, we've got our bracket there too. Okay. Go ahead and please feel free to pause the video. And again, that would be a continuous, but go ahead and feel free to pause the video if you have any questions on 1, 2, 3, or 4.